today's SS3 Mathematics live session, learnathome.ng. Today, we're dealing with theory of logarithms. In mathematics, there are two topics that deal with logarithm. The first is logarithm table, where you're going to have your table of values. Usually you see this at the back of your mathematics textbooks and some other textbooks. But today we are dealing with theory of logarithms. This is where we are going to treat some laws which involve calculations under logarithm. Okay, in today's session, I'll be introducing logarithm to you. That is, I'll be giving a definition so that you can understand what logarithm actually means. We'll go through the performance objectives. That is, some of the things that you need to have at the back of your mind while going through the process and learning. And as we move forward, there are some particular laws that you need to take note of. There are some particular techniques that you need to take note of. That's where we'll talk about that. Okay, and then we'll launch into today's lesson. Let's quickly hit the ground running. Performance objectives. We shall learn the definition of logarithms. We shall also learn the laws of logarithm. Today we'll be talking about just 4 laws, excluding the particular definition of logarithm itself, which makes it the 5th one. We are going to learn also to apply the law of logarithm to problem solving. We are going to learn the laws of logarithm, and we're going to use them to solve some problems. Okay, now the definition of logarithm. Logarithm is the exponent or power to which a base must be raised to yield a given result. Logarithm is the exponent or power to which a base must be raised to yield a given result. Logarithm can be said to be the reverse form of indices. That is, indices is the forward process, logarithm is the backward process. Okay, and in this example, we have 2 raised to power 3 is equal to 8. Of course, everyone knows that when you have a raised power, you are just supposed to multiply the number by the number of times you have in the power. That is, 2 raised to power 3 is equal to 2 times 2 times 2. In 3 places, 8 raised to power 2 is 8 times 8. In 2 places, 64 raised to power 2 is 64 times 64. 5 raised to power 3 is 5 times 5 times 5 in 3 places. Okay, so the power dictates how many times you're going to multiply that same number. Okay, that form is called the indicial form. That's where you learn indices. That's the meaning of powers. Okay, now to express this same indicial form in a logarithmic form, we say log 8 to base 2 is equal to 3. Log 8 to base 2 is equal to 3. Now, you will notice also that in the indicial form, we have the base of 2, and then we have the power of 3, which is equal to 8. In the logarithmic form, we have log 8 base 2. The base is also 2. Notice that the base in the indicial form and the base in the logarithmic form are still the same. 2 as the base in the indicial form, 2 as the base in the logarithmic form. Okay, so that should give us a clue, and that should help us in solving some problems. Now, I would like to give some examples, but before that, notice that we have log 8 to base 2, and I didn't call it log 2 base 8, neither did I call it log 2 raised to power 8. You pick the number that is standing upright, and then the number that is beneath in the subscript. Log 8 to base 2. That's how we read it, and it's equal to 3. Okay, so looking at some examples, I would like to give you another example. If I have this number 5 raised to power 2, of course, 5 to the second is equal to 25. 5 raised to power 2 is 5 times 5. All right, so expressing it in logarithm form, we're just going to say 2 is equal to log 25, the base must be the same here. 2 is equal to log 25. So if logarithm is the reverse process of indices, then of course it was indices on the left hand side. By the time it goes to the right hand side, it becomes the opposite, which is logarithm. Like you have 2x is equal to 4. Of course, you have to divide both sides by 2. The opposite of multiplication is division, and the opposite of division is multiplication. That's exactly what we're talking about. The opposite of indices is logarithm, and the opposite of logarithm is indices. Okay, let me give another example before we move on. If I have log 3 to base 10 is equal to 0.4771. If I'm changing this to indices, I'm going to have 3 is equal to, don't forget the base, which is 10. When it goes to the other side, it still becomes the base, but this time in this U. So we have 0.4771. So this is the conversion from logarithm into indices. Okay. We are still going to treat more examples on this as time goes on, of course. So moving on, these are some of the laws of logarithm. Log A to base B is plus log C to base B is equal to log AC base B. Notice that the bases are the same for both logarithms. This law is called the product law. The law is called the product law. Addition goes with multiplication. Okay, now for law 2, we have log A to base B minus log C to base B is equal to log A divided by C to base B. Also, the bases must be the same. Take note of that. Now, subtraction goes with division. Addition goes with multiplication. This second law is called the quotient law. Quotient law. All right. Law 3 states that log B to base B is equal to log C to base C, and is equal to log 5 to base 5, and it's equal to 1. The reason for that elongated expression is for you to know that the logarithm of a number to the base of the same number will exactly give you 1. So I could as well have written log 28 to base 28, log 1001 to base 1001. Noting that the number and the base should be the same for it to give me 1. Okay, so that's what the third law is saying. And the third law is called the identity law. You can note that identity law. Now, for law 4, we have the number being raised to a power of p. So now, what that fourth law is telling us is when you have a number being raised, all you need to do is bring the power of the number back to the beginning of the log. So it becomes log whatever you have times the power that you had. All right. So for instance, log d raised to power p base b is equal to p log d base b. We are just bringing the power behind the logarithm. Okay, that's what those laws are talking about. All right, let's launch out into solving problems. Example 1, simplify the following. Log 4 to base 3 plus log 5 to base 3. You notice that the two bases, the two logarithms have the same base. Okay, so to solve this problem, we just say log log 4 to base 5 plus to base 3 plus log 5 to base 3. And this will give us log 4 times 5 to base 3, which is equal to log 20 base 3. Now you notice that we use the first law, which is the product law. Okay, for easy reference purpose, I'll write the 4 laws at the topmost right corner. Log A to base B plus log C to base B must be equal to log AC to base B. That is log 1. All right, let me write my basis with a brighter color. All right, log A base B plus log C to base B will be equal to log A divided by C base B. We have B, B, and B. Observing that the bases are the same also. Also, for the third law, log A to base A is equal to, okay, this is the case where I have to write the base immediately so that we'll avoid confusion, and it's equal to 1, the identity law. And then finally, log A raised to power P base B will be equal to P log A base B. So all we just did is bringing the power of the number back to before the base. Okay, let's go back to example 1. We have log 4 to base 5 minus log 2 to base 5. The first thing we have to look out for is the bases. Are they the same? If they are, then we can apply these laws. If they are not, then we have to make sure that they are the same by expressing them in a particular form to make them the same, or leaving them like that. If we can't go further, we leave it like that. So this will give us log 4 over 2 base 5. Log 4 over 2 base 5, which is equal to log 2 base 5. That is the final answer to that. This looks easy, and actually it is easy. Okay, like it has been simplified. Now, problem C. The question says, evaluate log 3 to base 3. Looking at the laws, you notice that we are just going with the third law, identity law. This is just going to give us 1. And be careful to note that this is not equal to log 1. Altogether 1. Altogether 1. Okay, that is the simplest law you can ever learn. Okay, now for problem D, we have log 4 raised to power 2 base 3. This law is going with the fourth law, which states that the power of the number comes to the back. So we have 2 log 4 to base 3. This is the simplest we can simplify it to. This is the simplest we can simplify it to. Okay, now adding more, looking at this problem, if we have log 4 to base 2 plus log 5 to base 2 minus log 2 to base 2. We're going to apply the same rule. Now we are applying law 1 and law 2. Law 1 and law 2, the addition, which is the product law, and then the subtraction, which is the quotient law. Now, we can simply write it as log, open the bracket, the base is 2, the common base, and then we can write 4 times 5, then the minus is for division, all over 2. This gives us log 20 over 2 base 2. So finally we have log 10 base 2. Log 10 base 2. This is the simplest we can go, except we want to write the answer in decimal form. Okay, now this being said, we have some other problems. Let's look at this set of examples. Example 2. Since we're getting more familiar, the difficulty level will keep increasing. Example 2. We have log 8 base 2 minus log 4 base 2. Okay, the base is actually 10. Log 8 base 10 minus log 4 base 10 all over log 4 base 10 minus log 2 base 10. Okay, this is a question. To solve this problem, what we need to do is simplify the numerator, simplify the denominator, and then see if we can divide the final answer we get. All right, so simplifying the numerator, we're going to have log 8 over 4 from the second law all over log 4 over 2 base 10 base 10. All right, so we have log 8 divided by 4, which is equal to 2, divided by log 4 divided by 2 is 2 also, so base 10. Now you see that this number and the number beneath are the same thing, and of course, we can cross them out. Log 2 base 10 divided by log 2 base 10, the final answer is equal to 1. Final answer is 1. So no matter how complex a problem is, all we need to do is simplify the simplest you can. Simplify the simplest you can. Start dealing with it bit by bit. Deal with it bit by bit. A castle cannot be built as a whole. It can only be built bit by bit. Okay, now to solve another problem, we have problem B. Simplify log root 30 base 10 plus log root 2 base 10 minus log root 6, the same base 10. Now, like the last example I gave in the previous solution, we can apply the laws at once. This gives us log, since all the bases are the same, open the bracket, we have root 30 times root 2. For minus, we use division, divided by root 6. And this is as easy as it looks. The square root of 30 times the square root of 2. 2 times 30 is 60. So we have square root of 60 divided by square root of 6. Okay, now let's divide. 6 divided by 6 is 1. 6 in 60 is equal to 10. So we have root 10 to base 10. Root 10 to base 10. Okay, I would like to use another color for this basis. Okay, now this is the last we can go, but we also know that in indices, we've learned that when we have a raised to power half or a raised to power 1 over 2, this becomes the square root of a raised to power 1. Okay, so instead of writing the square root of a, we can also write it as a raised to power 1 over 2. And that's exactly what I would like to write this square root of 10 as. So I can simplify it to log 10 raised to power 1 over 2. 1 over 2. The 1 over 2 is representing the square root, and then the base 10. Okay, now you remember the last law? The power of the number comes to the back of the log and stands. So we can simplify this to 1 over 2 log 10 base 10. Okay, if you stop at this stage, well, you're close, but that's not the final answer. Remember law 3 stating that the number and the base should be the same. Okay, the number and the base should be the same. Log a base a is equal to log b base b, which is equal to 1. All right, this is log 10 to base 10. Everything here is equal to 1. So we have 1 over 2 times 1, which is equal to 1 over 2. This is the final answer. This is the final answer, half. So this is how simple laws of logarithm can be. Okay, now problem C. Let's do another problem. This is also very, very easy. You see kind of problems like this in competitive exams, also in terminal exams. If log 4 to base 10 is equal to 0.6021, evaluate log 4 raised to power 1 over 3 base, okay, evaluate log 4 raised to power 1 over 3 base 10. Solution. This can be done in 1, 2, 3 lines. Okay, now let's recall from the fourth law that the power first should come to the back. So I think we should do that first. Log 4 raised to power 1 over 3 base 10. I can decide not to write the base. If I decide not to write the base, then of course it's in base 10 automatically. Okay, this will be equal to 1 over 3 log 4 to base 10. What this means is 1 over 3 times log 4 to base 10. Now that we've been given the value in decimal of log 4 to base 10, we can easily say this gives us 1 over 3. By substitution, log 4 to base 10 becomes 0.6021. Okay, so when we are multiplying a fraction by a number, all we need to do is divide by the denominator. So 3 in 3 is 1. 3 in 0.6021 will give us 0.2007. This is the final answer. And if you write that, you get your full mark. Full mark. This is how simple theory of logarithms can be. Okay, this is the first part of the theory of logarithm. That's why we are treating only 4 laws. We have 8 laws. So let's solve problem D. Okay, problem D states that log 3 to base 10 is equal to 0.4771, and then log 5 to base 10 is equal to 0.6990. Evaluate log 7.5. Okay, now these are the kind of problems that students will see and then they'll take to their ears. But the truth of the matter remains that when we are solving a problem, we'll start solving it. Start. Sometimes you want to get to the end from the beginning. No, that is not the best way to solve a problem. You don't know the answer, that is why you're solving it. So start solving first, and then the steps will be coming bit by bit, and then voila, you see that you've solved the problem. If we are to evaluate log 7.5 to base 10, what we should remember is, how can I simplify this? We've been given log 3, we've been given log 5, we've been given log 2. But how else can I simplify this? Okay, remember that this is decimal. Usually when we are solving problems in logarithm and indices, we like not to use decimal. It is better to use fractions. So let's convert this 7.5 to fraction. This is the same thing as log 75 divided by 10, base 10. Okay, now we are going to reverse the process of the quotient rule. Instead of using minus to imply division, we'll go back and expand. This is the expansion form. So instead of writing log 75 over 10, we'll write log 75 base 10 minus log 10 base 10. Log 10 base 10. So if we bring this back, we know that this is 75 divided by 10. All right. Now, 75 can be written as 25 times 3 . 25 times 3 is equal to 75 base 10 base 10, Okay, we are going to do exactly the same thing. Multiplication, by the time we are expanding, becomes addition. So this gives us log 25 base 10 plus log 3 base 10, then minus log 10 base 10. Now we've expanded this, okay? We of course know that log 10 to base 10 is equal to 1. Log 3 base 10 we've been given from the problem. Log 3 to base 10 is equal to 0.4771. We're also given that log 2 is equal to, okay, we're given log 5 to be equal to 0.6990. These are the given values that we're told to use to solve the problem. All right. Now, log 25 can be written as log 5 raised to power 2 base 10 plus log 3 base 10 minus log 10 base 10. Basis at this. All right. Now, all we need to do is 5 raised to power 2 can be written from log 4. We bring the power to the back of the 5, the log 5. This gives us 2 log 5 plus log 3 minus log 10. All the bases being equal, base 10, base 10, base 10. All right. So we have log 5, 0.6990. We have log 3, 0.4771, and then log 10 to base 10 is equal to 1. Our problem is already solved. All right. So I would like to solve completely on this part. I'll complete the solution to the right. Since log 5 is equal to 0.6990, by substitution, we can see this is going to give us 2 times 0.6990 plus log 3, which is equal to 0.4771. Okay, then plus log minus log 10 minus 1. 2 times 0.6990 is going to give us, this should be 1.398, okay, plus 0.4771 minus 1. Then adding these two together, we're going to get 1.8951 minus 1. And so finally we have 0.8951. That is the final answer. This problem looks Very, very difficult, but it is not. We only went through the process bit by bit. So the solution being lengthy does not mean that the problem is hard or difficult. It just means that they are compounded problems, and then we have to dissociate them one after the other. So I think this is explanatory enough. All right. Now, moving on, we have another example. Now, this example deals with the definition of logarithm itself. It deals with the definition of logarithm itself. Okay. Example 3. Given that log x to base 3 is equal to is equal to 2. Then x is equal to 3 raised to power 2. X is equal to 9. Evaluate. Find A if log A minus 1 to base 5 is equal to 2 base 5. Okay, now from the definition I gave before, we converted this logarithm into indices. Remember I said that the base on the left-hand side, when it goes to the right-hand side, it still becomes the base, but this time around, it was logarithmic, it will become indicial. That's exactly what will happen here. We're trying to say A minus 1 will be equal to 5 raised to power 2. 5 raised to power 2. And 5 raised to power 2 is equal to 25. So we have A minus 1 is equal to 25. A minus 1 equals 25. Okay, so making A the subject of the formula, A will be equal to 25 plus 1. Finally, A is equal to 26. Finish. This is very easy to solve. Sorry for the break in transmission. So, like we said, the power of the number comes to the back here, which gives us this 2. The power of this number 3 comes to the back here, which gives us the 3 that we have. Now we have to substitute. Since they've given us this from the question, just substitute into the expression 2 times 0.4771 plus 3 times 0.3010, and then this is easy to add manually without calculator. All right, these are simple problems that we come by, but we think they are difficult. All right, a question is being asked by Taiwo Oluwapelumi. Log x to base 10. This should be written like this and not log x 10 or not log 10x. This means another question entirely. So when we are writing, we need to be very careful because the examiners take note of all these things. Plus, I know it might be very difficult to type in this, and I'm sure that that is exactly what you meant. Plus log x plus 3 base 10 is equal to 1. The question will say, find the value of x. Okay? Now, looking at this problem, this is plus. Two logarithmic expressions with the same base and with plus in between. We are using law 1, which is the product rule. This gives us log x times x plus 3 is equal to 1. Now it means we are multiplying the first number by the second number. So in doing this, we're going to have, now this is an equation, so we don't need equal to before it. We're going to have log, open bracket, x squared plus 3x base 10 is equal to 1. Now, like the last example we treated, stating that the number remains and then the base goes to the other side and still becomes the base. That's 10 raised to power 1. This is what we're going to have here. The base here comes here, becomes a big 10, which is still the base, raised to the power of the number that was there before. So we can rewrite this as x squared plus 3x. Since this is a quadratic equation, minus 10 is equal to 0. It's equal to 0. And here we go. We can finish up this problem using factorization method, using a graphical method, using quadratic formula, which we usually call almighty formula, and then we can use completing the square method. Well, any of the method you like to use, but I like to use factorization method from here. From here we have x squared plus 5x minus 2x minus 10 is equal to 0. This process is called factorization method. That's another topic on its own. Now, what's common between both of them is x. So we're going to have x plus 5 and then minus 2 in brackets x plus 5 is equal to 0. To finish up this problem, since what we have in both brackets are the same, we just pick one of them. We have x plus 5 and then the second one, x minus 2 is equal to 0. So finally we can say x plus 5 equals 0 or x minus 2 equals 0. That means x will be equal to minus 5 or x will be equal to 2. These are the values of x. Now, if you put these values of x one after the other, you put negative 5 here, you put negative 5 here. After adding, your answer should give you 1. If you also try 2, x, putting it as 2, putting it as 2 here also, after adding, you should get 1 as your answer. So those are the values of x such that this equation is satisfied. I hope I've answered your question. Now, I have one more problem for us to do. Let's take a look at this problem. Log a squared minus 5a minus 1 is equal to 0 base 5. Sorry, equals 1. Okay, like the last problem we solved, leave this number on the left. This gives us a squared minus 5a minus 1. This will be equal to the base comes over, becomes big, and then it's a power of 1. So this gives us a squared minus 5a minus 1 minus 5 is equal to 0. So we have a squared minus 5a minus 6 is equal to 0. This is another quadratic equation which should give us two answers. This should give us two answers. Now, we're also going to use factorization method to solve this problem. By factorization method, we have a squared minus 6a plus a minus 6 is equal to 0. A is common. Let's bring it out of the bracket. We are left with a minus 6. And then, since there's nothing common here, we'll just write 1. 1 can be multiplied by any number to give the same number. So we have a minus 6 equals 0. We have a minus 6 coming up twice. Pick one of them. We have a minus 6, then another bracket, a plus 1. So finally, we can say a minus 6 equals 0 or a plus 1 equals 0. Therefore, a is equal to 6 or a is equal to negative 1. Very, very easy. And that's the good thing about mathematics. All the topics are linked together. They are so intertwined. You can't learn one successfully without getting the other very well. It will still link up, and then you have to complete the solution. So when we are solving problems, you should learn all your topics very well. Thank you for joining us today. Thank you for attending today's session. I hope you enjoyed it. For further reading and a reference, please select Theory of Logarithms Content Lesson, available on learnathome.ng. Join us again next week, same time, for another exciting session. Thank you. Never stop learning.